Good afternoon, everyone. Ooh, that's a bit loud. My name's Liedig. I'm a solutions architect with the worldwide public sector team in Australia and New Zealand. It's an absolute pleasure to be here with you here in Washington. Thanks everyone for coming. So I'm from a place called Perth. Quick show of hands, who knows where Perth is? Wow, that's a lot. So for those of you who don't know where Perth is the remotest city in the remotest country in the world. And even there, we have this thing called the Monowhat. As you probably already guessed by the name, a Monowhat is a play on words on the word monolith. And it's typically the kind of reaction that I get with customers that when you tell them that they've got a monolith in their data center, they go, "Mono what?" And so you go about trying to explain what that is, and then I have to reach into my visual toolbox and explain to them what this is. And this is one of our more famous monoliths in Australia. Turns out that you guys have got quite a few monoliths here yourselves. Here's one of my favourites. But in all seriousness, the monolith is, when I was looking into this whole subject and doing some research, I found that which is typical in software, you can't find a single definition for any one thing. So I decided to go with this one from Wikipedia. And basically, monolith, defined by that, by Wikipedia, is a single-tiered software application in which the user interface and data access code are combined into a single program to form a single platform. It's self-contained, independent from any other computing applications. And that's great, but where do they all come from? The word monolith has, really has become part of the common day language that we have in IT. And, everywhere you look, people are telling you you've got one in your data center and that you need to start breaking it apart into microservices. And that's good and well. The pictures that are painted are, you've got this big ball and then you've got all of these other little round things, and they're effectively painting a picture of what you have and where you should be. Today's session is really all about trying to provide some guidance around some of the things that you might want to think about that aren't necessarily related to containers or serverless. So the word monolith is not something that I actually like per se. I think it kind of conjures up negative connotations and kind of gives you the impression that you've been doing something wrong all these years. Not something that that's aligned to the investments in time, money and effort that you have in building your applications. The way I look at these things is that our monolith is traditional applications, probably a better word for it. Applications that we've been developing over the last few years, we've been looking at we've been building them according to best practices and standards of the day. And just because you've got a traditional application in a data center, that doesn't necessarily mean it's been poorly designed. And what we haven't been, and what the cloud's been, really challenging us on is, building applications outside of the constraints of the resources that we have in our data centers now. And we've been building these applications not necessarily with the view to be distributed in nature. And so cloud is really providing us a whole range of options now that can help us think and build applications in a totally different way. So monolithics are really great when you start building applications. They're simple. You don't need to do any over-engineering on them. You can take advantage of in-process latencies. You've got a single code base that you can develop with, and you've got and they're really efficient at smaller scale. But they become a little bit more challenging when when they start to grow. Enforcing modularity and application design becomes a little bit more challenging. Scalability is also becomes a bit of a challenge. Typically, the only way that you're going to scale is by by scaling up. You start to draw more and more dependencies on your database. And the release cycles become longer. But probably one of the biggest the biggest cons for monolithic is that we start to, it's becoming we become slower to react to changes in customer demand. And we know what we're talking about because Amazon's been there. Back at the turn of the centuries, we had a monolithic application and teams that built around that. And we made the move many years ago, before microservices even became a thing, to move to that kind of development paradigm, and structure our teams around it. I know that there's been a couple of sessions that sort of explain the two pizza team concept, so I won't go into it today. But fundamentally, this is what our development lifecycle kind of looked like. We had large development teams working on a single code base, which required continuous integration, and we had a single delivery pipeline. Today, things look a lot different. Now, while this can be overwhelming when you first look at it, our move to microservices allowed us to build single-purpose APIs that are running over standards-based protocols like HTTP. And now our development lifecycle looks a lot different. We've got smaller development teams focused on building smaller, specific bespoke services, and each one of those has a delivery pipeline that's aligned to that service. And that's allowed us to build up thousands of teams, all building around a microservices architecture. Continuously delivering software across multiple environments. And that's allowed us to do up to 60 million deployments a year, and this is a figure from 2016. Now, the good news for you is that many of the best practices and tools and services that we use to build this we've made available to you. So operationally, you can take advantage of a lot of the developer tools that we have, CloudFormation and serverless application models to help you build out those serverless applications. And while we've challenged ourselves to change the way that we build applications, a big part of what made this a success is the changes that we made in our organisational structure to align to that architecture. And that's helped us deliver products and services to our customers far more rapidly, and has allowed us to pivot easily with change. So as you start to think about adopting microservices in your own organisations, this is something you should really start to think about. So let's have a quick review of our understanding of microservices. So again, this is one of those topics where you can have multiple different sources all telling you different things. So I've picked a few definitions that I've found while I was doing some research on this subject. And this is a really good definition from Martin Fowler, who describes microservices as an architectural style, as an approach to developing a single application as a small suite of services running in their own process and communicating over lightweight mechanisms like HTTP. This is an excellent definition but is a really technical definition as well. It talks a lot about the implementation kind of details that you need to consider, which is really good. Here's a definition from Sam Newman, his colleague, who talks a lot about microservices being autonomous and independently deployable that work together, that are built around a business domain. And I like this definition because of that last piece in that sentence, business domain. We can't forget about, while we get caught up in the technology, we can't forget about why we're actually building these services in the first place. So my personal favourite on that vein is this one from Udi Dahan, which describes services or microservices as the technical authority for business capabilities. So this makes no assumptions around technology, deployability, and puts a really strong emphasis on business capability. And that comes in really handy when you start to think about, or when you start to see companies telling you that you've got your monolith and here are all these services. You've got your shipping services, talking to the inventory, talking customer service and accounts and so on and so forth. And they might draw these diagrams with different shapes, but fundamentally there's an assumption here that they already know what those boundaries are. The real challenge for you as organisations and companies choosing to adopt microservices is fundamentally defining these boundaries and finding ways to communicate between the various services. The technology is the easy part. This is actually the hard part. So to help us along with this, we can look at things like domain-driven design. Now, domain-driven design was a book that came out a long time ago by it was written by Eric Evans, and it fundamentally describes a broad framework for making design decisions and helps us build up a technical language around about how we can describe the domain. And he talks a lot about the ubiquitous language. And that ubiquitous language is fundamental to modelling the language of the business. Now, if you're like me, and if you've read this book a couple of times, I always started off on chapter 1, learning all about how to build the actual model itself, focusing on entities and value objects, repositories, services, and so on and so forth. And that's great if you want to be able to learn how to tactically implement all of that stuff. But some advice that I got from Udi Dahan and guys like Greg Young was that the real value in this book, the book should have actually started around about chapter 11. So if you haven't read this book, don't start at chapter 1, have a look at the elements around strategic design. The elements around strategic design and why this is important, they focus around a couple of different things. One of the core concepts, an essential modelling tool within DDD to help you actually build up microservices as well, is this whole concept around bounded context. And they help us identify explicit boundaries around our understanding of the ubiquitous language and the things that people really care about in your organisation. And they help us understand how to model different multiple business concepts that may appear to us to be exactly the same thing. Now, it took me a little time to figure out what that was and what that actually meant. Vaughan Vernon, in his book, actually implementing domain-driven design, had a really good example that really clarified that whole concept for me. And he talks about modelling the concept of a book in the context of publishing that example. And so he goes through this whole description around, a book being initially just nothing but a concept, right? It may have a title, it may have a description, or it may not. And as it moves through that whole publishing process, we start to interact with other elements of the business, such as contracting. We might be starting to manage the book's authorship and editorial process. We're going to be looking at things like, designing book layouts, transformation into other languages, producing physical print or electronic versions of the book, right through to marketing, selling, and finally distribution. And the point here is that it's going to be very difficult for us to interact with all of these stages if we only have one model of the book. So we need to determine how a book is operating in its individual context. And that's what bounded contexts really help us with. Of course, bounded contexts aren't any good unless you start to get a global view of how they interact with each other. And that's what we look to context maps for. They provide us with the mapping of different but related ubiquitous languages by integrating their bounded contexts. And there are several patterns that you can apply that Evans and Vernon describe in their books And some of these you may have already heard of, things like shared kernel or anti-corruption layers, open host services. Another element of domain-driven design that Vernon introduces into his book is this whole concept around a domain event. Now, I've been developing software applications for some time, and I know that this is not something that has been implemented consistently in the project, at least that I've worked on. Typically, we spend a lot of time identifying the nouns and those objects in our applications to help us, establish relational data models and the like. But we hardly spend any time modeling objects in our domain that represent that something has happened. And as you start to, and this becomes critical as you start to think about building up, particularly like serverless, event-driven applications, this becomes an essential modeling practice. So defining domain events, we look to creating immutable objects that are representative of verbs in the past tense, things like customer created or policy changed. And they should be really lightweight. And they fundamentally become the pattern for integration of our different bounded contexts and communication between our various microservices via patterns such as publish subscribe. So once we've got a reasonable understanding of what our domain looks like and how our ubiquitous languages interact with each other, we need to think about other things like coupling. Now, fundamentally, all software, including microservices, are about managing dependency, striving for loose coupling and high cohesion within our services, and especially around a high degree of encapsulation. And this hasn't changed since the dawn of time, really. There are multiple types of that coupling that you need to be aware of. So the first one, and where most of our application developers typically will spend their time, is drawing dependency at an application level. And we've got two types of coupling that we can use to help us measure the degree of coupling that our applications have: afferent and efferent coupling. This is fundamentally saying who depends on you and who do you depend on. We've got other forms of coupling like platform coupling, which get introduced by things like proprietary protocols and components that are very platform specific. Now, luckily, as organisations start to adopt more of a standards-based approach to communication, this is becoming less and less of an issue. But it's something that you need to be aware of, particularly if you've got a more traditional application in your databases, in your data centres. Now, a more difficult form of coupling to identify within your applications is this concept around temporal coupling. And this deals with time-based dependencies between collaborating components within your system. Things like wait operations or dealing with sequential processing. And then we've got things like spatial coupling, which is essentially providing an abstraction of where on the network your services are actually living, and providing mechanisms for failover of those components, so you can continue processing in the event of a failure. And things like elastic load balancing and auto scaling can really help with that. But just like the spoon in the movie The Matrix, there is actually no loose coupling. As we've just sort of described, coupling is a function of multiple dimensions. So you can't just have loose or tight coupling. It's not a binary scenario. And along the way, we need to think about all of those things and make trade-offs so we can be more effective around how to define and deal with our bounded contexts. Now, one of the ways that we can deal with coupling, and something that isn't really mentioned a lot in the context of microservices, is where messaging and messaging patterns can really be of help. Now, I want to focus on two particular services that AWS has that are going to help you deal with this. The first one is Amazon SQS. Now, Amazon SQS provides you with a simple, highly reliable and available service that helps you with durable messaging between multiple endpoints. It's highly durable, persistence across multiple availability zones. It's highly available across all AWS regions. And in terms of the reliability components, one of the things that it supports, like many other messaging middleware, is this whole concept around dead letter queues. And this is really important because you can start to, in the event that you've got message failure, you can start to automatically recover and build business functionality around that to help you recover from failure. Now, unlike your traditional messaging middleware, SQS is fully distributed, which means that you don't have to worry about, and it's fully managed, so you don't have to worry about managing any of the underlying infrastructure and using APIs to define and build queues within your system. And doing that is as simple as creating a single one-line command. One of the things that we have been working very hard on and what our customers have been asking for of late is the ability to have SQS as an event source. And we pre-announced this at the San Francisco Summit earlier this year, and I'm happy to say that this is something that's coming very soon. And fundamentally, from a serverless or a Lambda implementation, it basically means that Lambda is going to be responsible for polling those polling queues for you. And when it detects new messages, it's going to invoke your Lambda functions by passing that message on as an event. And you're still going to have full control over the same queue processing settings, visibility, timeout, and even support for batch processing. And it's going to deal with the polling. It's going to deal with the polling rate by gradually increasing that as you get more and more messages on the queue, and also pulling back when your message queue count starts to drop off. And it's got full support for identity and resource-based policy from a security perspective. So this is fundamentally going to change the way that you're going to build serverless microservices and be able to adopt messaging as a first-class citizen. The second important messaging service I wanted to talk to you about in the context of microservices is a simple notification service. Now, this is, again, highly reliable and available, but it's a durable publish-subscribe service that helps you deliver messages to multiple destinations. And it has integration already with services like Lambda, but also many other services as well. It's highly durable and persistent across multiple availability zones and is highly available across all AWS regions. And something that we've introduced at the end of last year is this whole idea of being able to filter on message delivery. And I'm going to talk a little bit about that in a second. Just like with SQS, there's no infrastructure for you to manage. You don't have to have a heavy middleware platform to take advantage of the publish-subscribe mechanism that SNS supports. It's as simple as you can create a topic with a single line of code. Now, from a publish-subscribe perspective, the whole idea behind that is to have a single logical publisher and multiple subscribers. And this whole design pattern allows us to address multiple forms of coupling, including spatial and temporal coupling. And the messages that get published by these logical publishers can now be consumed and acted upon by each of the respective microservices in their own way. And SNS really makes that easy and helps us more adaptable by providing multiple subscription channels such as Lambda, SQS, HTTP, SMS, and also mobile push notifications. Now, from a message filtering capabilities, once you start to implement a publish-subscribe pattern within your architecture, you can do a number of different things. So what customers have been doing is they've been looking at modeling a message to a logical destination. So we've got, in this example, a grey message and a blue message, and each have been mapped to a specific queue. And this This is totally acceptable and totally fine, except for a couple of things. First of all, as your messages start to grow, you're going to have a proliferation of topics. And also the responsibility of deciding how to route those messages are solely the responsibility of the publisher. So what we've introduced is SNS message filters. And this basically allows you to embed message attributes onto the message that you're publishing, and allowing subscribers to that topic to be able to specify a subscription policy. And this takes away the need for publishers to know how to route messages to their final destinations. And subscribers don't need to process every single message that gets published on the topic. They can simply decide which ones they're interested in. And this helps with infrastructure management and being more logical message distribution. We've also made some enhancements recently that help you do things such as exact matching on string values, matching on prefix values, and anything but messaging. Matching on string values. And we can also start to do some interesting stuff with numeric comparisons and looking at filtering on numeric ranges as well. So you're going to be able to do some really interesting filtering in the pub/sub context. Now, another thing you want to think about when you start building up your microservices and defining your bounded context is dealing with long-running processes. And from a Lambda perspective, people have been trying to orchestrate intricate workflows by doing something that we call message function chaining. And this is basically one function invoking another function invoking another function. And this is not a great design. I have to say, there are better ways to do this. So what I mean by that is that we're dealing with we're dealing with spatial coupling, because one function needs to know about another function, needs to know about another function. And we also need to worry about things like failover and state management as we do function calls. One of the things that most of the time what we're looking to do is providing a way to do things like retry failed states, sequential task processing, so defining a specific workflow around how we want to execute our functions, try catch, and even potentially parallel processing to help us manage a whole sequence of parallel execution streams and then correlate the results for all of those. And to help us do all that, we look at AWS Step Functions. And this helps us easily coordinate the components of our distributed applications using a visual workflow. Now, how this is defined is through a JSON-based specification called a states language. And this helps us visually build up these workflows that we can then use to orchestrate the execution of our Lambda functions. And what this does, it offloads the responsibility of that execution flow to the service and takes the orchestration logic out of your code, so you can be very focused on single responsibility practices and being able to deal with things like failover in a very, very simple way. And it provides us a mechanism for state management as well. So putting all these things together, when we start to look at messaging in a microservices context, and with the ability to have SQS as an event source, we can start doing some really interesting messaging patterns within our microservices. Things like one-way fire and forget execution, really highly durable cloud-native request response patterns as well, and return address, which allows logical publishers or commands to be sent with message attributes that determine what queue the final destination or the response should be sent to. And finally, you've got things like publish, subscribe. So some final thoughts on all of this microservices stuff. One of the things that we don't really talk about when we're dealing with microservices is the actual user interface. And while we can do all these great things at a back-end level, what we tend to forget about is the impact that that will have on our user interface and the coupling that we can start to draw on our services at a UI level. So if we go with the definition that Udi brought out, is that if the microservice is the technical authority for a business capability, then surely how users interact with that service is also an element of that definition. And so we need to start thinking about how can we leverage composite user interface frameworks to help us deal with that. So in summary, chances are you're probably not going to need microservices, right? If you've already got a well-defined domain, then you won't probably have to break your monolith apart altogether, right? Look at the things that really matter to your organisation and the pain points in which microservices could help. If you're starting, if you start, and don't go big bang either, right? If you're starting to break up your monolith, you've made that decision, then work around the periphery of your domain and your application, right? Look for things that aren't going to provide you some quick wins, and build up some capability and use that approach to build up some capabilities and start to establish some patterns within your new architecture. And remember, it's an evolutionary journey, right? You're going to learn as you go along what it means to start to adopt microservices and help to support them. And finally, and consider whether or not a monolithic approach, or monolithic first approach, is going to be a viable option for you to start with greenfields applications, right? This is going to help you define what your bounded contexts look like. If you go ahead and you start creating these microservices around boundaries you don't understand yet, bringing them back together is going to be a bit of a challenging task for you. And lead your microservices strategy from a strategic perspective, right? Model your services around business capability and leverage messaging services to help you deal with things like coupling and enforcing those bounded contexts within your microservices architecture. And that's me. Thank you very much, and hope you've enjoyed your summit, and I'm happy to take any questions if you have any. I beg your pardon? Yep. Yeah, so good question. So the question was, how do you re-architect to start breaking up dependencies in your database? Again, it's looking at defining what your boundaries are, right? You don't necessarily have to go polymorphic. You don't have to necessarily change your database engine, for example. You don't have to go to NoSQL, but what you could do is look in terms of ownership, right? Again, this is about defining ownership, about finding boundaries not just in your business processes, but also who owns that data, right? And you know, domain events really kind of help you. Once you start to model those kinds of things, you can define the relationships that tie those bounded contexts together to help you identify where the seams in your database should be as well. Does that answer your question? Cool. No more questions? I'm going to be around for a little while. If you want to speak to me about anything, I'm happy to talk to you. Thank you very much.